Okay, hello and welcome to my tutorial um, to maps and filters. And I'll start with a very simple thing here. So here we have a function. It takes a character, and if it is between A and M, it adds 13. Also, if it is between capital A and between capital M, it does the same. If it is between lowercase or capital N and Z, it subtracts 13. And what that does is the simple rotation chevre, and it automatically reverses itself when you apply it twice. Okay, so it is not very strong cryptographically, but it is still used in news groups for to guard against sufficiently dumb spam bots who cannot decrypt ROT13. But I'd say every spam bot can now decrypt ROT13 and knows that the answer to every second char is 42. And well, now this is my example. We like to apply this function to a string. So we like to say write-len rod13 hello world, right? This would be nice if D would automatically recognize it takes a character, but we apply it to an array, and now apply it to every element in that array. And if we now try to compile this, filters tutorial emd main d, right? It says it takes a character, it is not callable using the argument type string. Well, what do we do now? Thankfully, lcd.algorithm has a facility called map. And what map does is you specify a function and a range, which can be an array too. And map takes every element of that range or of the array, applies the function to it, and then you can get it back. It iterates this lazily. So if we want to put an array in and we want to get an array out, we have to call std array.array to get all elements, to iterate this map completely and store the result in an array. That is what std.array does. And let's try this. So we say map. Now there's a template parameter. This template parameter takes a function, in this case the rod13 function. That is then automatically applied to the hello world string, and this should transform this hello world here, but it should not touch the exclamation point, and capital letters should still be capital letters. And if we take the result of that and use rod13 on it, it should still give us hello world. Alright, so we compile it. Unidentified. Yes, it's rod13, not rod. Okay. Okay. Um, this string is actually stored as as a sequence of decars and not as a sequence of cars. Um, we can trivially make a workaround for that by just specifying a new overload. That just says decar rod 13 decar pure, and this just does the worst thing possible. It casts it calls rod 13. Right, this just casts it and calls the other function. This is might not very efficient, but it is a fix, and this should allow this to compile. Not dub, of course. Declaration rod 13 is already defined. Can't we use function overloading? It seems we can't use function overloading in this case. Yes, it's because we overload the return type. We can't overload return types in D, and with reason. Now it should work. It still doesn't work. Well, is a car text a decar? Could it be that this does not call the correct overload? Or that we can't use a function overloading inside of a closure? That could actually be the case. So let's try it like this. Of course, we just have to call main. Right. We can't use function overloading inside a closure. That is good to know. Okay. And we call main. And it says, you'll be back. We copy this. And we paste it into our hello world. And what we should get out actually is hello world. Okay, let's compile it. Let's call main again, and we get hello world. So our rod 13 works. What have we learned? We have learned that a map can be used to apply a function meant for a single element to a whole array. Now, what is this filter business? Well, we could say that for some reason we hate the letter H. Yes? And we want every H letter to be filtered out of the output here. So the H in hello world should go away. So we say filter, and then we specify a binary predicate. Okay? And this binary predicate says we make a lambda for this. This makes the letter that we get L must not be equal to H, right? If this predicate evaluates to true, then the value is forwarded to right len. If it evaluates to false, then the value is not forwarded to right len. So if we compile now, we should actually get hello world without the H, right? Like in French. Let's try this and we get hello world. So this is how filters work. You specify a binary, not a binary, a boolean. You specify a boolean predicate, apply it to that function, and then you're done. Okay, thanks.